Hello, this video is for STA2023, Statistical Methods, Chapter 7, Section 4, Estimating the Population Proportion with Confidence Intervals. So here's an example. The Pew Research Center took a random sample of 2,928 adults in the United States, and in September 2008, in this sample, 53% of the 2,928 people believed that reducing the spread of acquired immune deficiency disease, AIDS, and other infectious diseases was an important policy goal for the U.S. government. This percentage is just a sample. What is the percentage of the population? We don't know P, the population parameter, but we do know P hat, the sample proportion. So when we calculate confidence intervals, the ones we're used to are 68, 95, 99.7. 68 is one standard deviation in either direction, 95 is two standard deviations in either direction, and 99.7 is three standard deviations in either direction. Excuse me. So step one, find your SE. So to find the SE, it's the same form as before, but instead of using P, which we don't have, we're going to use P hat. So when we don't have P, we use P hat, but P is always preferred, because that's everybody. So we do square root of P hat times 1 minus P hat divided by n, which is 0.53 times 1 minus 0.53 divided by 2928. The square root of it all gives us an SE of 0.009. Again, be careful with that. Now, if I wanted to find out a 68% confidence interval, the formula is P hat plus or minus 1 times the SE. Now, why is it 1? 68% is 1 standard deviation. So in this case, we do 0.53 plus or minus 1 times 0.009, the SE. The minus gives us 0.521, and the positive plus gives us 0.539. So we can say we are 68% confident the proportion of adults who believe in reducing diseases is important is between 52.1% and 53.9%. Now remember, what this means is we don't know P. We're using P hat to estimate P at a 68% confidence interval. So if I changed it to 95%, notice what happens. Same formula, P hat plus or minus, but instead of 1, we use 2, because 95 is 2 standard deviations away, times our SE. So we do P hat plus or minus 2 times your SE. So 0.53 minus 2.009, and 0.53 plus 2 times 0.009, which gives us 0.512, 0.548. So we are 95% confident the proportion of adults who believe in reducing disease is between 51.2 and 54.8%. Now if I want to go to 99.7%, now the formula changes to 3 instead of 1 or 2, because 99.7 is 3 standard deviations. So in this case, it'd be 0.53 minus 3 times 0.009, and 0.53 plus 3 times 0.009, which gives us 0.503 and 0.557. So we are 99.7% confident the proportion of adults who believe reducing diseases is important is between 50.3% and 55.7%. Now before we move on, let's talk about what happens to the interval. So the first interval was 52.1 to 53.9. That was 68%. The second interval was 51.2% to 54.8%. And the third interval, 98.7%, was 50.3% to 55.7%. Notice as the confidence goes up, the interval gets wider. The reason why it gets wider is 2 reasons. One, obviously because we're multiplying by a larger number, it gets wider. But the reason for it is, if you think about it, is the more confident we are, it's because the interval is wider. The wider the range, the more numbers that fall in it, the more confident we become. Okay? So looking at this, your question is, oh, is that always going to be 1, 2, or 3, 68, 95, 90.7? No, it could be any percent actually. The real formula is this. P hat plus or minus a Z star times your SE. Now Z star is related to that 68, 95, 98.7, or any percent. Now this section here, the Z star times SE, is something you're probably familiar with, and that's called margin of error. You may people say, oh, there's a margin of error, plus or minus this, there's a little spread, there's a difference, right? That's where you get the margin of error. The margin of error is when you take Z star times your SE, and that's the number we add or subtract from your P hat. That's our cushion, our margin of error. Now other Z stars, besides 68 is 1, 95 is 2, 99.7 is 3, well, 99, 2.58. 95, 1.96. Now this may be a little worrisome because we just said 95 is 2. The exact number is 1.96. 90%, 1.645. 80%, 1.28. Now these are common Z stars, but you can do any percent. How do you find the Z star for any percent? Well, using the table, here's what we do. So if we draw a picture, if I wanted to find the Z star for 95%, I would have my normal curve. I would label out 95%, which would be in the center, and then that would mean if the whole thing's 100, there's 5% left, but there are 2 tails. So 5% divided by 2 is 2.5, 2.5. So let's make sure we understand that. We're looking for 95, the Z star that goes with 95. 95 is in the middle, therefore to add up to 100, this has to be 2.5 and this has to be 2.5. Now the reason why I do that is the Z star is like our Z score. So remember, if we use the table goes to the left, So if 2.5%, which is 0.025, 2.5% is 0.025, I'm looking for this section here. So to find that section, there's the percent changed to a decimal. If we find the Z score, that's our Z star, and the other one has to match because it's the same distance away. So if I go back to my Z table, which will take me a second to get back there, we're looking for 0.025, 0.025. 0.025 is what we're looking for, so we're scrolling. Okay, so we go to our Z table, we're looking for, in the center, 0.025. 0.025 would be this one here, and we're going to match it up with the Z score. So there's our 0.025, negative 1.96, negative 1.96. Okay? And that's where we get our negative 1.96, which means the other side would be positive 1.96, and we use the Z star of the positive. You can actually use either one, but we traditionally use the positive. So here's another example. If I want to find the Z star for 99, so the Z star for 99, I put the 99 in the center. Remember, the whole thing is 100%. The whole thing is 100%. So that'd be 1% left, but 2 tails. So we have 0.5%, 0.5%. Again, 0.5% plus 0.5% is 1, plus 99 gives us the 100. So 0.5%, be careful, is a decimal, is 0.005. So we're going to look for 0.005, match up the Z score. So I go to my Z table. The closest to 0.005 would be between these two. Now to be honest, you can use either one. You can say negative 2.57, 2.58, or if you want to be a little more exact, 2.575 to be right in the center, but either one's fine. Notice here I did negative 2.58, so the other one's positive 2.58, so Z star would be 2.58. So that's how to find the Z star using the table. So we'll do one example. Do the majority of Americans believe the profession of teaching is prestigious? A 2007 Harris poll took a random sample of 1,011 Americans and found that 49% of the sample believed that the profession of teaching has very great prestige. Find an approximate 90% confidence interval for the percentage of all Americans who believe teaching has very great prestige. So we're looking for 90%. N is 1011. P hat is 0.49. That's where P hat came from. They gave us the fraction. If you want to see how the Z star comes from, 90% is here. 5 and 5 adds up to 10, plus 90 is 100. If you look up 0.05, the exact number is negative 1.645. We'll use the positive one, 1.645. It's also one of the common ones in the table. Then we find our SE, square root, P hat, 0.49, times 1 minus 0.49, divided by 1011, which is 0.016. So the formula says we need P hat plus or minus Z star times your SE. P hat's 0.49. The Z star is 1.645. The SE is 0.016. When you do 0.49 minus 1.645 times 0.016, you get 0.4637. 0.49 plus 1.645 times 0.016, 0.5163. So we are 90% confident the proportion of Americans who believe teaching is prestigious is between 46.37% and 51.36%. Remember, we don't know P. We're using P hat to estimate P using that margin of error.